Hey, hello. All right. So, welcome to chapter 11 of mole concept and stoichiometry. So, this is a continuation from last lesson when we learned about atomic mass, molecular mass, and isotopes. So, today's section about mole concept and stoichiometry, we're going to learn four main concepts, which is the mole. We're going to understand the association between the mole, molar mass, and mass of the substance. Understand the association between mole and volume of gas at room temperature, and calculate the two types of concentrations for solutions. Okay, so the first concept of mole, we need to know that mole is a standard unit. Okay, and it represents 6.02 times 10 to the power of 23 particles. Okay, so we have to know this number when it comes to mole. Any one mole of any substance contains 6.02 times 10 to the power of 23 particles at any point of time. Okay, so we can just ignore this triangle. It's a bit more confusing, but just know that this is one mole, 6.02 times 10 to the power of 23. All right, and then we look at the association between mole and mass. Okay, and we introduce this concept called molar mass. Okay, so if you learned previously about molecular mass, in the previous lesson we learned about molecular mass, which is the MR, which is the average mass of one molecule compared to 1/12 of a 12C carbon, right? Molar mass is similar, but the definition is different. Okay, it is the average of the definition of molar mass is it is the average of average of 1 mole of a substance. Okay, but essentially it is usually used synonymously with molecular mass. Okay, so don't be confused when these two terms are used interchangeably, because they have different definitions, but actually the name, the molar mass and molecular mass of each molecule is the same. Okay, but the thing we need to take note of molar mass is the units are always grams per mole. Okay, so when identifying the relationship between mass, molar mass, and mole, we can think of it as a triangle. Okay, so mole times mr is equals to mass. Okay, essentially, which is over here as well. Mass equals to molar mass times mole. Okay, we can look at it in terms of the units as well. Molar mass is grams per mole. Okay, and mole is of course mole, and mass is grams. Okay, so the units to check out. All right. So MR, you can see it from your molar mass. You can see it from, you can calculate it from your periodic table, like how we did with molecular mass last lesson. We flip this equation around. We bring molar mass here, and we can find the number of moles for each mass of a substance, which is a very common question that they like to test. All right. Okay. Then next we have molar volume of gases. All right. So molar volume of gases, similar to how we calculate. Okay, maybe not so similar. Okay, but essentially you need to know this concept of 24 dm cubed. One mole of any gas occupies 24 dm cubed at room temperature and pressure. Okay, this is the same for any gas as long as it is at room temperature and pressure. Okay. has to be at room temperature and pressure. Okay. So we can see here also the triangle. 1 mole times 24 dm cubed, you get the volume of that gas at room temperature and pressure only. Okay. Why must it be at room temperature and pressure? Okay, so you have to take note that I think you probably learned it previously as well, that the volume of gas will change with temperature and pressure. Okay. When you increase temperature, when you increase temperature, usually the volume will increase as well. And when you increase pressure, the volume will decrease. Okay. So that is the relationship. So that is why it is important to specify room temperature conditions, because it's only at room temperature conditions that it is 24 dm cubed. Okay, for 1 mole. Okay, so this example, I won't really be going through. Next, we go to the last concept, which is concentrations. All right. So concentration in simple terms is the amount of solute in a volume, in a specific volume of solvent. Okay. Amount of solute in a volume of solvent. Okay. If you don't know what solute is, it is just a compound solid that is dissolved in a solvent. And a solvent is a liquid used to dissolve any solute. All right, so they are usually used together. Okay, so amount of solute can be in mass or mole. All right, which means that our concentration is in mass or molar concentration. And the question would like to usually they would like to test they like to give sometimes your answers will have to be in mass concentration, sometimes it has to be in molar concentration. So this is something that you have to take note of when you look at the questions. All right. And essentially mass concentration, when we look at it, is in, if we look at the units, it is in grams per dm cubed. All right. That's because to get the mass concentration, we divide the mass of the solute that is dissolved over the volume of solvent that is being used. So to give you an example, all right, when the salt solution has a concentration of 1 gram per dm cubed, what does this mean? This means that in that concentration, in that solution, right, 1 gram of salt is dissolved in 1 dm cubed of solvent. Okay, that's the easy way to put it. All right. Same thing for mole. 1 mole is dissolved in 1 dm cubed. Okay. So that is the way to understand mass and molar concentration. It is the amount of solute that can be dissolved in that volume of solvent. Okay. So maybe to give another example, let's follow this example of what is the concentration of the solution when 0.4 moles of sodium chloride is dissolved in 3 dm cubed of water. Okay. So like we learned previously, so they are asking for, so they give us in, their question is asking for concentration in molar concentration. Okay. So we have to take note of this. Okay, and we look at the formula, molar concentration calculated by dividing the number of moles of solute by the volume of solvent. Okay, so 0.4 moles is dissolved in 3 dm cubed of water. So we're using the equation, we divide number of moles of solute by the volume of solvent, 0.4 by the amount of solvent. Okay, and we get 0.4 divided by 3, we get 0.167 mole per dm cubed. So this is the final molar concentration. Okay, so in this case, Sodium chloride is the solute. Water is the solvent. Okay. And so there's a very quick recap of what you should have learned for this lesson. The four concepts of mole, relationship between mole, molar mass, and mole, molar mass, and mass. Molar volume of gas, which is a relationship between mole, volume, and 24 dm cube, which is molar volume, and concentrations. The two different types of concentrations being mass and molar concentration. Okay, let's go to the worksheet. So let's go into the worksheet. All right. So today's worksheet, there is quite a lot of questions to go through, 10 MCQ questions, and we'll go through them together, all right? So, like what I mentioned earlier, four main concepts that you should take away from today's lesson: mole, molar mass, molar volume, and concentration, okay? Okay, so let's do the first question. Which of the following contains the greatest number of atoms? Okay. Okay, when we think of the number of atoms, we look at, there should be one concept that comes into mind, and that is your Avogadro's constant, okay? They will always ask about number of particles, number of atoms, and we always think about Avogadro's constant or or the mole concept, okay? We always look at the mole, okay? Because one mole is 6.02 times 10 to the power of 10 to the power of 23 particles, right? That is one mole. A mole is a standard unit, okay? So we look at the number of moles. Okay, so in this case, right, when we are looking at number of atoms, the easiest way of doing this is just to count how many atoms are in each compound. All right. So we look at ammonia here. Ammonia has 1 nitrogen, 3 hydrogen. Okay, which means that for each compound, for each molecule of ammonia, one molecule of NH3 ammonia has 4 atoms because 1 nitrogen and 3 hydrogen. Okay, same thing for hydrogen gas. One molecule of hydrogen gas is H2 has 2 atoms. Okay. One molecule of sulfur dioxide has 3 atoms. Okay. And one molecule of zinc has 1 atom. Okay. Because it is just zinc by itself. Okay. So one molecule of ammonia has 4 atoms, which also means that 1 mole of ammonia has 4 moles of atoms. Okay. So let's bring this here. That means 1 mole of ammonia has, because if we split ammonia into just its atoms, we get actually 4 moles of atoms, which is 1 mole of